Alright folks, let's do number 44. The height of a helicopter. So let me draw a helicopter. Whatever. I don't know what the you know what, my drawing skills really do suck. Okay, whatever. Helicopter. Screw it. Okay, so this is going to be a helicopter. And its motion is given by this equation, 3t squared. And we're going to ignore the units because they ignore it too. So, cubic. Okay. So, where h is in meters and t is in seconds. After 2 seconds, so we're going to let the t be after 2 seconds. But before we do that, let's visualize this. What the heck's going on? So, the helicopter is going to be having some initial height after 2 seconds. Okay? So it's going to be this cubic shaped thing. So this is going to be the t-axis. This is going to be the h-axis or the y-axis, and it's going to and that's going to look like that. So it's going to fly really high up there, and after 2 seconds, it releases it back. So because the bag is sharing the motion with a helicopter, it's going to share its initial velocity, folks. So think about what's visually happening. When you go fly in the helicopter and you're holding a bag, and as the helicopter is flying up, the bag is also flying up with you. So it's sharing the velocity, it's sharing the components, and then after it releases it, as it's flying up, and we can know, and if you take the derivative of this, the change of the height of the helicopter to respect to time, the velocity is going to be 9t squared. So after 2 seconds, we can find the initial velocity of the helicopter, and we can set up the motion. In fact, let's do that. I'm speaking a lot, but I can't speak for shit, to be honest. But anyways, so after the helicopter releases the bags, that means that would be 8 times 3, which is 24 meters. Is where it's going to be initially be. So the height here is going to be 24 meters upward somewhere after 2 seconds, and then after 2 seconds the speed is going to be 9 times 40, which is 36 meters. So that means that this is going to be 36 meters per second upward. That's going to be the initial velocity after the helicopter releases the bag. So during that momentarily. So that's another way of saying that the initial velocity of the bag is 36 meters. And since it's not going to be tied to the helicopter anymore, it's going to be in free fall. Free fall meaning without air resistance, even though there is air resistance. But let's exclude that. And we're just going to take into the account the force of acceleration being due to gravity coming downward. So how long after it releases does it reaches the ground? So that's another way of saying it's going to go up, it's going to go a little up, and then it's going to go back down. That's the motion graph. So in other words, folks, the motion graph is going to be some initial position, which I'm going to call capital H. Capital H being 3 times 2 to the 3 times 8, which is 24 meters. There we go. Minus the plus the initial velocity, which the initial velocity is take the derivative to respect to t. Plug 2 equals there. So 2 times 4 is 4 times whatever, 36 meters. There we go, beautiful. There we go. And minus the force of gravity, which is 9.8 meters per second squared. There you go, beautiful. Okay, so gt squared over 2. Beautiful. Okay, there you go. So there's the motion graph. This is the actual motion graph of this parabola-looking shape after it releases the bag. So the question is asking for how long after it releases does the mail bag reach the ground. So that's another way of saying when this is 0 meters, you have some initial velocity plus v naught t minus g over 2 t squared over 2. So you're going to use the quadratic formula. So this is going to be negative v naught plus or minus the square root of v naught squared minus 4 minus or plus over whatever the heck 4 g over 2 times h all over 2 over negative g, which is going to be, there you go, beautiful. So all you have to do is take that into account. And I think we're going to, since this is going to be a minus and a plus, since we're going to suspect when you put the plus portion, you're going to get a minus. I'm going to change this equation a little bit. I'm going to just put the whole plus in there and say, screw it, that's going to be the equation that we're going to be looking for. So the actual time is going to be v naught plus or minus square root of b squared minus plus 4 ac. It's basically your math. Use your math skills, use your TI-84 calculator, do whatever the heck you have to do, and then you're going to find the time it takes. So once you find the time, I already got it. So and I confirmed this. So the time here is 7.96 seconds. And I really encourage you guys not to go as fast as I did on this channel because I make a lot of embarrassing mistakes. But that doesn't really matter because the important is that you start to understand what the heck you're even doing with the motion graph. So there you go, folks. I hope this helps. Let me know in the comment section below. Subscribe to the channel new and help this channel grow. All right.